and we'll record it to the computer. And we'll share screen. Okay. Now, what I will do in future recordings of Zoom sessions is at the end of the class, I will send you the video link so that you can review it. Again, if there are questions you have, you can review it and as a YouTube video. So it will end up being a YouTube, and I'll give you guys access to it. It will not be generally available. I will be I'm teaching this class both morning and evening, and I'll be recording the morning class because the evening class is much shorter, as you probably already know, so that we can, in the evenings, I can concentrate on stuff that we can't do, by Zoom, like the labs. So what I would like to do is have you go to your shell and bring up the modules. And I'd like to start with the module that's called Course Home. You'll note that there is a copy of the syllabus there. There's also a syllabus on the sidebar. They're the same. We have the LRA Part 1. Let's go to that immediately. And the LRA, you'll note that there is a missing link here. I've been trying to get that out, and I can't seem to edit it out. So, but eventually that was just a recording. I think that was going to lead to an APA description. You've all done enough APA papers by now that I don't think we have to go through that. So we're going to go and choose a medication, a drug, from page 550 in the text. And you will make the choice as to what drug you'd like to study. What I find is that a lot of times people will have family members taking drugs, and they'll say, well, gee, I'd like to know what this drug is doing for my Aunt Sally or whatever. That's perfectly good. If you don't have anyone who's taking any of the drugs on that list, randomly pick one. Part of pharmacy is understanding drugs, how they work, what they do, how to dose, how to do dosage calculations with the drug. That is a good portion of what pharmacy is about. Pharmacists know more about drugs than doctors. And the reason is that doctors study drugs in their first major class in medical school, which is a class that most of them call something like human pharmacology, which basically is how do drugs work in people. Well, of course, when they're taught that class, it's at a specific point, a specific time, and there are always new drugs. They learn something about drug interactions. All drugs have the potential to interact with each other, sometimes to enhance the activity, sometimes to cause problems. Pharmacists, however, study all of those different topics, and they study them continuously. So if you have a question about a drug, as a patient, ask your doctor for sure, but then ask the pharmacist because they know more. That's their job. Okay. So what we want to do is find a couple of reputable sources, at least two. I prefer at least three, but I'm not gonna change that right now. At least 2 pages. Now, when I mean at least 2 pages, I don't mean 1 3/4 pages. I mean 2 pages plus. I will guarantee you, any of the drugs on that list, you can find 80,000 pages worth of information. Your problem is to distill out of that what you need to know to answer the information that's down here on the bottom, which is brand and trade name. Well, what is a brand or trade name? Well, that's the name that pardon? Ah, there's a blue one here. All right. So let's just look at Motrin, which is a drug you probably know. It has a little symbol in it there, R. The R in a circle means that it's a registered trademark. Okay. This name belongs to the company that is now known as Pharmacia and Upjohn. But Motrin is a name that only they can use. Every drug has also a generic name. So we have a trade name. And a generic name. Is ibuprofen. Generic name is public property. Anyone can use it. Okay. Now, the difference between a generic name and a generic drug is that when a drug is developed, it's patented by the pharmaceutical company. It gives them a certain amount of time in which they can be the sole marketer. The whole purpose of patents was to encourage commerce, the development of commerce. It was written into our Constitution as a means of doing that. It actually comes out of the old aristocratic habit of appointing people to do certain jobs for the crown and giving them the exclusive right to do that. Patents have a lifetime. The lifetime of a patent now worldwide is 20 years from the day you actually submit that patent for approval. At the end of that 20 years, anyone can make your product and sell it. Now, if I invent something like this little pen that we use to write on the board, I can probably sell this thing for 20 years if I patent it. No one else can duplicate this. And the way patents are written, no one can duplicate something that's almost like it, because we write patents to include a broad, a broad sphere of products that do the same thing or look the same. Okay, so I can get this for probably 20 years. Pharmaceutical products, however, can't just be invented and sold. Used to be. But now we have this thing called the Food and Drug Administration that has to approve that sale. The average amount of time that it takes for a new drug to go from the point at which you actually identify what it is and know that it can be has the potential to be a drug is between 8 and 12 years of development time. Plus that, and that also includes the time that the FDA takes to review and approve it. So right away you see that the actual life of a product to a pharmaceutical company is much lower, much shorter than that 20 years. Now, there are ways that they can extend it. There are all sorts of patent tricks they can follow. And also, there are some rules, there are some laws that we'll talk about in a minute, after which other people can make the drug. And they can market it as the generic named product, or they can develop their own trade name. Now, unlike a patent, a trademark A trade name doesn't have an expiration. As long as you're willing to pay the annual fee, you own that trademark. It's very valuable. It's the only intellectual property that has no endpoint as long as you continue to pay fees. Okay? So other people can manufacture this stuff, and you see it all the time. You've got Walgreens brand, you got Kirkland brand at Costco, you've got, everybody has, pardon? 7-Eleven brand. They're probably all made by the same. They're probably all made in the same. If you look at them, they all look alike, right? For the most part, they're the little rust-colored tablets, right? But they can be sold, and we can use that name. We can call it Motrin. To do that, we get into trademark infringement. That is a legal issue, and they can get you taken off the market. But when I manufacture it, assuming that literally I can manufacture it. Now, in order to sell it, I still have to be approved by the FDA. But I become a generic manufacturer. That's what a generic drug is a drug that is identical to an existing product that is going off patent. Okay, so that's the difference between a generic name and a generic drug. Now, the difference between the generic name applies to what we call the active ingredient in a drug. A drug really consists of the active ingredient and a whole lot of other stuff that we call excipients. And what they are is binders. If you took the amount of ibuprofen in a typical 200 milligram ibuprofen tablet and compressed it into a pill, it would be about that big. That's all. And you couldn't take them very easily. I mean, homeopathics, we already know you can do that with pills that small. People take them as homeopathics all the time, but these are not homeopathics. So also, these things, by their very nature, I'm a chemist by education. That's my background. I was a chemist in the pharmaceutical industry for a long time and did many, many other things as well. But if you take something like generic, the active ingredient here, ibuprofen, and try to make it into a tablet, it'll fall apart because they don't like to hold together. So we add other things, sugars, starches, waxes. We put coatings on. We use colors and dyes and lots and lots of things to actually make the drug. And the FDA has to approve our manufacturing process as well. The FDA also has to approve our manufacturing facility. This is why, even though I physically could make an ibuprofen product in my garage, I couldn't sell it because the FDA wouldn't approve my garage as a manufacturing facility. Okay, so there's a lot of things that go into this, and this takes years and millions of dollars. Okay, I'm not using that as an excuse for the high prices in the pharmaceutical, but it's a fact of life. Okay, and the number that they give you for the average cost of developing a drug is totally bogus. The actual cost of developing a drug does go into the hundreds of millions of dollars, but not to billions of dollars, which is what people are saying today. I know enough of the economics of that industry to know that that is just a bunch of economists using economist speak and double counting. Okay, so you want to know the brand name or trade name and the generic name of your product. Now remember, the generic name is the generic name of the active ingredient, not of the drug itself, because the drug is all of these other things combined. When it was originally approved by the FDA, okay, so you need to go back into sources. The drug schedule, meaning, is it a controlled substance, such as an opiate, or a minor tranquilizer, or an expectorant? There are 5 classes, 5 levels of schedule for drugs. Okay. Have you guys been through that discussion about the DEA schedules in your other classes? Okay. So we know, so find out what the schedule is if it is a controlled substance. Most drugs are not. Okay. What is the dosing schedule for a, quote, normal, healthy adult? 30 to 50 years old. No, it's really more like about 25 to 55. When drugs are developed, people have to volunteer to be a part of the development schedule. No one can be secretly given a drug. So in order to volunteer, though, you have to be an adult. So you have to be old enough to sign a consent form, which nowadays is 18 years old. But you get up into the mid-50s and later, and our metabolism's changing. You know, we've beaten our bodies up over the years with, you know, just life, diet, alcohol, cigarettes, all the things that people do. So we change the way our bodies handle drugs. So in general, most pharmaceutical companies will not experiment on a drug, most drugs, initially at least, in patients that are under 18 because you have to have parental consent, or people over 55 because we don't handle drugs the way you guys do physically. Indications. Indication means what is it approved to treat? And I mean, what is it approved? The FDA gives approvals. And you will see if you look at the FDA's website and look at new drugs, new approvals, what you'll see is most of the new approvals are for either alternate dosage forms or for other uses. There are very few drugs that are approved that we call new chemical entities, meaning something that's never been approved for any use before. Last year was a record. There were 40 some odd drugs approved originally last year. That's about twice the average when I was in the industry. Okay, so we've got, we don't have many of them, but there were hundreds of approval actions by the FDA. Now, some of those, as I say, were alternate formulations. They may be approval for a new manufacturing facility. There may be a lot of things. Okay, contraindications. What can the drug, what condition might a patient have that the drug would be inappropriate? Let's just say you have a patient with kidney disease. If you had a drug that was extensively cleared by the kidney, you may want to avoid that or think about how you dose that drug. Because if the drug is cleared by the kidney and the kidneys aren't working, you're going to be building up toxic levels in the body. Other things might be some of our drugs active in the central nervous system for depression or psychosis also can cause seizures. So you wouldn't want to give that to a patient who's already known to be an epileptic. Okay, so look for contraindications. Where do you find? They're in the labeling. These are sections of the labeling. Common side effects. Okay, now every drug has common side effects. You see it on the packaging. You hear it when you see a drug commercial on television. What do? They say, you may experience, and then they go through this litany that seems to go on forever, and the guy speaking as fast as he possibly can in as low a voice as he can get away with. And it starts off with mild headache and nausea and goes to sudden death. Well, we'll talk about clinical trials another time and why we have that. But sometimes drugs will do that. Common side effects are things that people get as a regular, as a very common event. Ibuprofen, common side effect, stomach upset if you don't take it with food. It's very rough on stomachs. Okay, so that's a common side effect. What we're looking for here is the things that you would tell a patient generally, you may experience this. For any oral medication, you're going to have nausea, vomiting. Okay, people just respond that way. Sometimes bodies don't like drugs, and sometimes the stomach just pops it right back out. So the other thing is commonly headache. Okay, what we're looking for is things that affect, um, liver effects. A lot of drugs have a liver or kidney effect because they're metabolized in the liver and then cleared through the kidney. So these organs see these drugs. And so what you want to do is look for those common side effects. There are many drugs that have very rare side effects. In fact, most drugs have very rare side effects. And the difference between a side effect and what we call an adverse drug reaction is basically severity. Headache is a side effect, rather minor. Yes, it is annoying, but it's rather minor. Sudden death or kidney failure, though you'd probably agree, were adverse drug events. So it's really about severity. Pregnancy category. Drugs can affect the development of fetus. If you look at a drug and you choose one of the cholesterol lowering agents, say pravastatin or one of those, you will note that it's pregnancy category X, meaning at no time during pregnancy should a woman take the drug. Why? It interferes with cholesterol metabolism. Why is that a problem? Well, what are our cell walls made of? Cholesterol, long-chain fatty acids. Yeah. Yeah. Iron tablets. A lot of people have that side effect, that reaction. Yeah, yeah. What you're going to be losing then is, remember, baby takes hers first. We saw that with our babies. My wife's in our second pregnancy. My wife lost 23 pounds in the first trimester because she couldn't eat. She had such terrible morning sickness and got dehydrated. Yeah. That too happens. Again, when you have a child growing within you, it changes your metabolism. And as I say, baby takes hers first. I mean, that we saw that. I mean, the baby, our second baby was fine when she was born, even though we had a very rough first trimester. And so that is one of the things that you have to think about. But if you mess up important pathways, and cholesterol biosynthesis pathways important, we make enough cholesterol in our bodies for our use. That's one of the reasons they keep griping about, fatty meats and cholesterol and everything, although we're beginning to understand that that's not true. It's not cholesterol that's the problem. It's more of an inflammatory disease that they're worried about. But you'll find that there are pregnancy categories that range from perfectly fine to take when you're pregnant, all the way to X. So we've got, A, B, C, D, X. At what stage? Second trimester. Okay. Iron is really a toxic metal. It is what we call a trace element. Yes, we have iron, it's part of hemoglobin, but the amount of iron, the total amount of iron in our hemoglobin is very, very small. And iron itself is a heavy metal and it's toxic. And so what happens if you have to be careful when you take it. First off, the iron tablets themselves really are nasty to your stomach. A lot of people have trouble taking them. And we're better off looking at our diet and finding iron-rich vegetable sources, heavy greens, that sort of thing. But too much iron can mess up a number of different metabolic pathways. I've not heard of it being associated with breathing problems, but everybody's different. And the interaction between mother and baby is such that it may have been messing up some of the things that your body was able to transfer to your baby. Right, well, yeah. One of the reasons that we tell people, don't drink, don't smoke, don't take drugs during pregnancy is because we don't know what that actually does. We do know about things like fetal alcohol syndrome. And we also know that smoking has an effect on the fetus. But all drugs do. That's why most drugs fall into a category that we don't have enough information to know if there's an effect on a developing fetus or not. And so we have a caution that says, use with caution with pregnant patients because we don't know. And drugs can change their pregnancy category as well. Okay, we are, great, we have a visitor. Okay, we're about to take a break, so come on in. Yep, I've got one. Yeah, it would be useful. Oh, they're hiding. Look in a drawer next time, Mike. Right, we've got one of those. Oh, a new one. Great. Super. Thank you. All right. No problem. Okay. Thank you.
And then I'm the new librarian or assistant librarian, so if you guys need me, I will be doing that. And I'm also the IT guy stuff. So I'm just still hanging things.
Well, thank you. Why don't we go ahead and take our first break? We are a few minutes late, I see. I think we are. Yeah, just a few.
So if you need a break, we can come and find him in his room, which you can help him take it out. Well, maybe we can just have an old time. Because he has his phone really quick, he knows it. So every time I try to recover it,
So is it through Gmail? Yeah. Probably more than likely you're going to have to call Gmail and tell them the whole situation, or Google tell them the whole situation, because he's going to get emails about his your phone hasn't been verified, so he's going to instantly, oh, that was not me, so it's going to cancel that action. And of course, your your password has changed. Was that you? Of course, he's going to get that and he can actually cancel that as well. So well, there's another way you can do it is set up another Gmail. Gmail is free, of course, so there's always that option, but it's so much of a hassle to just go through and try to remember all the things that are linked to that Gmail. And if it's your Gmail and not like a shared Gmail, it's going to be a lot easier to do. So I suggest just give them a call and tell them everything, tell them the situation. Like, this is the number that needs to be linked. And then, of course, this secondary email needs to be removed from this account. I'm the primary. Just was a figure in my life, but now he's not. And they should be more than willing. Yeah.
Yeah. Okay. All right.
That help?
Yeah, so if you can get this out, give me a copy.
Okay, so let's take our first break. We are on break. Okay, I'll be back in a couple of minutes.
Dude, I don't know what he's talking about. Well, I know everything he's talking about, but. What kind of glitter do you use?
The next,
Really? I've never seen that with that. I never, like eyeliner glitter, that's so good.
dude, I'll do more stuff.
I can do eyeshadow, I don't know that, but that's so cool. I like it. It's like perfect for my eyes.
Oh yeah, dude, I go to the club sometimes and oh my god, the compliments I get.
I don't really love it.
You don't?
I just need contacts. I don't really want my glasses.
Mhm.
You know.
Yeah.
You know, my opinion. I don't need contacts. There one guy is a librarian there. He was like stairs.
I know him because we had Paul. He was doing all his practice and stuff in our class. Yeah. So like he was being a student teacher or whatever. And he can start this month or last month. Start teaching or something. I don't know. The class did you take last month? Dude, I'm scared.
Like, I mean, not like.
Need a paper towel.
It'd be so hard. It's just so hard.
Me so much.
Oh, be so worried.
I mean, that's only if you're in Mexico, you can still go. You can still log in and everything. If you're just trying to pass.
Yeah.
So if they'll go. Give me the links to the answer.
Right?
This year got me thinking like, oh, when you're, you know, you're, I'm thinking of at all.
I don't want to. Again, never. Dude, my last, okay, so I got a new job. I wasn't working, dude. Like, my man was like buying me all my shit, but like Christmas was coming out, and I was like, I ain't gonna ask him for money to fucking buy him shit. Like, buy him stuff, so I got a job or whatever. deliver pizza for Domino's. Dude, I make good money, but like the tips are fucking bomb, dude. Every delivery I take for like $20 in tips. I get to keep those. Yeah, and then so
Only in a couple hours. I'm trying to look for another job. I work across the street from my child. So if you're trying to get some, just give it to me up here. And I can get to you.
what do you mean?
I work right here at Westcott Child across the street. Have you been there? Dude, you gotta go there.
What is
It's
that?
like Plato's Closet, like the little kid stuff.
Really?
All toys, clothes, shoes, like
Really?
gloves, nose, swimwear, everything.
Oh my god.
You've never been there?
I've never been there.
Everybody sells stuff. We only like brand new. We only sell it for like 30, 40 or what it's worth. You can get high chairs.
Dude, I didn't know that there was a place to like go sell
Exactly.
baby stuff because
Do that, dude.
usually I just give my stuff away. Like I have so much stuff for my daughter, and I just give it away or like I can throw it away too because shit. My daughter
You could sell it there and give you money, cash. Oh. Have you been to Once Upon a Child?
Pardon?
Once Upon a Child?
No.
She has a baby. She doesn't know about the store.
I'm sorry?
She doesn't know about the store.
Oh, really?
I work there, and it's like, if you know how Plato's Closet works.
Uh-huh.
We sell
Right.
clothes and we sell it. It's exactly like all baby clothes.
I've heard about it, but I haven't been there because we don't have any babies. Our daughters have yet to produce grandchildren, so we have to adopt them.
Oh, when you're ready, go in there and you can find almost anything can relate it. That probably isn't soiled like we don't buy like baby.
Sure. Well, and babies grow out of things so fast.
Exactly.
When we had our babies, we had friends who were having babies a few years beforehand. We had so many care packages. We almost didn't buy any baby clothing because our friends just sent them to us. So, and then those that were possible, we passed on to the next round. So, you know, but I'm glad that we have places that can do that. And that's where you work?
Mhm. I'm trying to think. I thought I just saw him.
Yeah, he's here.
Okay. Where? You should go. I'm right next door. It's called Mentor at Evening. It's like Plato's Closet. Okay. It's just classy. It's classy clothes, not too much.
My computer needs to.
But it's all cheaper because everybody sells their stuff there. Everybody sells it. You should go there. It's so cute. You walk in there and you're like, I really love this place. You have clearance channels. Go with it. Everything that's on clearance.
So let's go back to the LRA because this is something that I want you to get used to. This last category, something interesting about the drug, can be a wide range of things. You may run into some weird side effect. Yeah. Albuterol?
And I really want to know, like, well, I know that you have to like, drink
Mhm.
it.
Okay.
What causes all the
Okay. So what I will do, now that you've given me your choice, we'll get Sarah E. to give us her choice as well. Have you made one or thought about it?
Well, there is no like in enough, thyroid secreting hormone, but um, yeah. Don't know which medication is.
Which, what are you looking at?
Um, not a thyroid activator. Somebody who has hyperthyroidism.
Well, there are thyroid suppressants
Yeah.
that we use. I would rather, if you can identify it, then we can talk about it. The guideline here is in the top 25 of these drugs, which number one is not on the top 25 list itself. The generic form, atorvastatin, is. But Lipitor has gone off patent since this list was compiled. Nexium may have as well. And actually, probably the leading product on the current list is number 7 on this list, Synthroid.
What page is that on?
550.
I thought it was so cute how you said our pregnancies like you ruin your life.
Well, she didn't get pregnant by herself.
I know some things.
My grandmother was quite a character. My family, my mother's family came from the hills of Western Virginia. And my grandmother was apparently quite a character. My mother was one of 9. And one of her second youngest sister had 4 babies. And when she was pregnant for the 4th time, she was really just angry at her husband. Okay. So she was telling that to her mother. She says, I'm really angry at Bill, blah, 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 blah. And my grandmother looked at her and said, well, you weren't exactly hanging up laundry when it happened, were you? So at that point, my aunt said, oh, well, yeah. I guess I wasn't. But anyway, yeah, well, it was our pregnancy. I mean, as I say, I did participate.
My husband.
Yeah. Yep. So,
No, I get it all the time. I already have one. But finish school first. She's so small.
how old is she?
She's
3. Yeah, it's a great age.
this is her.
You've got a 3-year-old across the street from us, who's just as cute as she can be, and she has 8-year-old twin sisters. They're sort of becoming grandkids to us.
There is twins in my family.
Uh, Yeah. Yeah, from one of the off this list, the top 25 there on page 550.
Oh, my pajamas. She loves coffee. I don't know what's wrong with her. It's better best screen.
Well, if you're having trouble, Anthony's the guy to talk to.
Yeah.
And this list is actually kind of misleading because it's the top 200 brand name drugs. The actual top 200 drugs have an awful lot of generic products on it, non-brand products. And in fact, the top probably levothyroxine, which is number 7 on this list, Synthroid, is the trade name. But levothyroxine has a number of different generics. And it's actually, in terms of numbers of prescriptions written per year, is actually the leading drug in this country at the moment. The next one down used to be Vicodin and its generic copies. Number of years ago, but Vicodin has been upgraded in schedule to Schedule 2, which means they're much more controlled in the amount of these drugs that can be given. But it's still a leading drug. Hello there. No problem. You do need a sink. That's okay. So, is there something that sparks your interest, Sarah E? Seroquel. All right, you got it. There are generic albuterol.
Yeah.
They're not real big because the issue is that you've got 2 different here. You got ProAir and Ventolin. Yeah. ProAir and Ventolin are just different trade names from different manufacturers. The HFA is the propellant. That's hydrofluoroalkane. Okay, so that's what the HFA is. It's a biologically inert propellant gas that pushes the stuff in. There is Advair Discus does that. Yeah. Okay. Okay, Seroquel. Done. Okay, so I will actually post a short list of of what your topics are so that everybody knows what everyone's doing. Now, where do you get information? There's a lot of places. One of the things I want you to avoid, however, is Wikipedia. And the reason is that Wikipedia, for all of its efforts to appear to be neutral, they can't possibly be because it's user updatable. And guess who writes all of the drug entries? Every drug has a Wikipedia page. Guess who writes them? The drug companies. Now, they're a form of advertising, so the law is very, very strict about what they can and cannot say. But the law doesn't tell them how to say it. So they're not going to be out there emphasizing the side effects and problems with the drug. They're going to be talking about what they consider the good stuff. So it's not a trustworthy source, primary source. However, you can find lots and lots of other sources by going to their reference page. But remember who writes it. They're not going to put down all of the things that say bad things about their drugs. So what you want to do is there are several other sources that can be used for investigating drugs. One of which is drugs.com. There's WebMD. And actually, I think drugs.com owns WebMD. We've got rxlist.com, globalrph.com. RPH means registered pharmacist. Okay. And you have FDA.gov. And those are places to start. Now, there's a lot more information out there than just that. There are many other sources. These are the ones I primarily use. So what I suggest you want to do is go to them, get a little information, look at the structure, see which one works best for you. I happen to like rxlist.com, but that's because I understand its structure. It has the same information as everyone else, but I understand its structure better. So I can get information much more quickly than others, simply because I've used it more. Okay. Look for blogs, especially the drugs you've chosen are used by large numbers of people. Drugs they all have problems. They all have side effects. They all have interactions with other drugs. Look for those. Look for a blog. This is user experience. Now, remember that blogs, the majority of people that post on blogs are people that are angry, especially about drugs. People have had problems. So be careful about taking them as being really good sources of information. However, people do post their problems. And, you know, again, with the internet and with postings like blogs, be careful of the motive of the person who's doing the posting. Sometimes the motive is they're angry because their Aunt Sally took this drug and she died suddenly. Well, the drug may or may not have been related to that. People don't understand cause and effect. Maybe the drug was the problem. Maybe it wasn't. So you have to be a little careful, but look for that. Okay. But sorry. Okay. Okay, here you go. Oh, good.
Yeah. It's really good. It tells you like contractions, uses, symptoms, things to look out for. It's really good.
You have it on your phone?
Yeah, there's an app for it too.
Yeah.
Yeah.
Yeah, it's good to have it on. That's another good source of brief information, but it tells you a lot about that. It also does some things that very carefully summarize some of the issues here, such as the dosing for normal people. Very well summarized. They also are not limited to the approved indications. They will actually talk about other uses that the drug may be that may be applied by physicians and dosing for those. So there's a little bit more information there than some of the official sites. The FDA has the official labeling. In other words, the material that you when you pick up a prescription at the doctor, they give you this sheet of information always, or rather the pharmacy. They'll give you a sheet of information. That is all approved by the FDA. None of the advertising and promotional material and informational material that's out there about drugs officially can be distributed without the FDA's review and approval. So they're very careful about what can be said. Okay. So you'll be doing the part 1 of the LRA is actually due on January 27th, which is, I think, the end of the 3rd week of class. We will actually discuss in the 4th week, you'll make a presentation about your drug in class. Informal. This is the writing assignment. There's a second, however. The presentation is something that you'll do, yeah. And really, the presentation is will summarize what you know about the drug, but then you have the part 2 of the LRA is patient teaching. One of the things you do as I don't know what your plans are for when you graduate, but of course, one of the last classes you take here will be Med 299, which is what we call the clinical capstone. Basically, you'll review all the clinical skills that you've learned. Phlebotomy, hematology, injections, and everything. We will really review everything you've studied. It's a very intense class, especially when I teach it. I can't speak for other people who teach it, but when I do it, you're very, very busy reviewing. The whole idea is that your final in that class is to actually take your first certification exam. Okay. Now, many people opt for the medical assistant exam. And that's because it's the whole class is geared toward general knowledge, and that's what the medical assistant exam covers. But you can also choose any of the ones you want to take. Pharmacy assistant or pharmacy technician, you can choose medical assistant, phlebotomist, patient care tech, etc. You can choose the one you want. Pardon? We want you to take more than one, but for the class, you take just one. Okay. You can only take one exam a month anyway. Okay. So I don't know what what your plan is, but if you are going to be working in a physician's office as an assistant, a medical assistant, you will have the opportunity to educate patients, to teach them about the drugs that they're being prescribed. And so part 2 is a patient teaching plan. Okay. So you're going to have to make up a patient, basically. And you'll present this in class. This is a presentation. You will be grading each other on your presentation, as well as I will be grading you. And one of the things you'll find is the grading rubric. So you'll see exactly what we're looking for in the presentation. But the description here, again, generic name, drug name, why it was prescribed, how and when are you to take it? What's the schedule? Do you take it, morning and evening? How many units of the drug do you take? Whether it be 1 puff or 2 puffs on the inhaler or 1 tablet. Does it need to be taken with or without food? Does it matter? Sometimes there are drugs that you have to take with food. Other drugs have to be taken without food. The antibiotic tetracycline is a good example. You want to take it on a fasting stomach because when you put food in your stomach, what's the first thing the stomach does? Generate a bunch of acid. Acid destroys tetracycline. So you don't get any benefit from the dose. So you want to take that on a stomach that's been fasting for at least 2 hours. And then you want to give it at least half an hour before you eat anything. Okay. So that's one of the things we want to take it. How long is the course of treatment? Well, for an antibiotic, it's anywhere from, you have a Z-Pak that lasts 4 days to, you may have a very severe, say, gram-negative infection that requires a 30-day course of vancomycin, which is one nasty, nasty drug. So you want to know how long that treatment. For things like Seroquel or albuterol, basically you're going to take it for life. It's going to be a long course of treatment. You're going to take it as long as the drug is being effective. Okay, so that would be a course, a typical course. Follow-up. When should the patient come back? With antibiotics, we always tell them come back or call us within 3 days and let us know what's going on. Because if it's not getting better, we gave you the wrong antibiotic. Simple. You've all heard that with your kids. Side effects. What do you expect to see? Precautions. Do you have to take it with meals? Should you not drive? With some of these, with many drugs, you're told don't drive or operate heavy equipment. So if you're a welder, you're kind of stuck, right? That's pretty delicate, dangerous work. Signs and symptoms of an allergic reaction. You'll note I didn't mention allergic reactions as a side effect in the LRA Part 1 because every drug has that as a potential side effect. People can be allergic to anything. We're finding that the titanium pins and rods we put into broken bones, people are starting to be allergic to titanium. And we used to think of that as an inert metal. Nope. People can be allergic to anything. In fact, it's very common to have drug allergies. With things like albuterol and Seroquel, those allergies aren't real common, fortunately, because an awful lot of people take those drugs. But with things like antibiotics, for instance, I can't take penicillins or sulfa drugs because I have a very extreme reaction to them, an allergic reaction. So fortunately, I never get sick. At my age, I take no prescription drugs. That's unusual. In my age group, I would be expected to be taking 4 to 6 prescription drugs right now, and I don't. I'm lucky. I inherited my father's genetics on that. That's why he's 101, because he doesn't take drugs. But we have that. But allergic reactions are common. People can be, as I say, allergic to anything. Okay. So what do you do in the case of an allergic reaction? What do you think the first thing you do when you think that you're being allergic to your drug? Yeah, but stop taking it right away. Because allergic reactions never get better, they only get worse. Okay. So we have a grading sheet that you can look at. You'll see what we're going to be. You're going to grade each other on, and remember that you're going to be, even though you're going to be talking to each other when you're doing this, and you guys are in the medical program, so you speak the medical language, don't use that because you cannot trust that your patient understands anything medical. I don't care if he has a PhD in astrophysics, he might know doodly squat about medicine and probably does know doodly squat about medicine. So don't assume that they understand any abbreviations or when you give a patient handout, medical short terms, any of that. Don't assume that they understand anything. Okay. Rarely will you find someone that will be insulted by that. So even if you know they're in the medical field, what you need to do is get into the habit of not using, obviously if you're going to talk about a broken femur, you're using a medical term. But when we're not taught, when we don't use like, oh, well, you take your Vicodin PRN. That doesn't mean anything to anyone who's not in medicine, right? It means something to you guys because you know what PRN is, but most people haven't a clue. So we're going to you're going to prepare an information sheet on your drug, short information sheet. You've seen these information sheets when you've picked up prescriptions at the pharmacy because they give them to you all the time. So you know the kind of information that's there. And then you're going to actually discuss it with the patient, with basically the class. And then we'll grade you on that. All right? So questions? All right. Let's talk about yet another assignment. The news flash assignment. And this is something that, again, is part of the research portion of this class. The news flash is about staying up with current activities in the field of pharmacy. Since this is a pharmacy class, that's what we want to do. There's something new every day. There are a number of websites that have lots and lots of information. Epocrates is one. One of the sections of Epocrates is a daily alert, and which they will highlight interesting studies about drugs or treatment protocols or a lot of other different things. They also have a rather interesting picture quiz on a regular basis. But what you've got other things as well. There's a website that I get alerts from fairly regularly. And I'm not sure what NPR means. It doesn't mean Minnesota Public Radio or any of that. But I'm not sure what that is. But it is a medical sort of news service that is, puts out material almost every day, and they regularly put out alerts about new drugs, okay, that are being approved, or extended uses, or alerts about drugs, safety concerns that have arisen in the practical use of drugs. So that's a good source, but you can also look at the FDA's website periodically. But what it says here, because this is actually designed for a much larger class, a minimum of 2 students at the beginning of each class will separately present news, and we'll have a sign-up sheet. There's only 3 of you in this class, so there's no reason for us to push this until the 3rd week of class. And so what I would like to do is have you guys commit to a date to make your presentation. And we'll put that definitely on the calendar, and I'll actually have a schedule that I will post in the shell. So, the 3rd week of class actually begins on the 22nd of January. So that's the 3rd week. Okay. So remember that we're going to be doing presentations of your research, and you're going to be doing the LRA Part 2 in the 4th week. So I'd like the 2 of you to do the news flash in week 3. Does that work for you? Okay. You might not be here the 22nd, right? Oh, you could always come to the evening class if you could make that. 6 o'clock. Okay. Yeah, it's fine. I mean, I'm not saying that I want you to do it that day, but you know, I'm just saying that'll keep you from missing one class. Yeah. Yeah. Okay. Okay, so let's do 124 for both of your presentations, okay, of the news flash. I would start looking now for something interesting. I mean, and it doesn't have to be flashy. You don't need to do fancy PowerPoints or any of this stuff. If you want to, that's fine. There's nothing wrong with doing that. But it's the information. And we have a, obviously, you have the ability to the mention here is that we can also use Medscape, but read through all of this assignment. We're looking for something that's probably between 5 and 10 minutes of discussion rather than a lengthy presentation, and concentrate on the information. And the other thing is, it says down here, don't panic. A lot of people get nervous about standing up in front of a group and talking. But remember, we're all friends here. We're not going to throw tomatoes at you or do anything or jump all over you and tell you what a lousy job you've done. We're not going to be doing any of that. I guarantee you'll run into that in the workplace. There are people who think that it's appropriate to behave in that fashion.
Go out and get food. They feel worthless, and it's like you just need to chill. You learn stuff.
Yep.
I have friends who are they're stressing out.
You do come out with a lot of knowledge and some skills. And the skills, the thing about the knowledge, however, as I said before, the knowledge is what you learn at the time. How you apply that knowledge and how you stay current in your field determines just how successful you're going to be. You do have to be willing to dedicate some time. Everything has two components to it. Every job in the medical field has two components to it. One is the certification side, which requires also continual education, continuing ed. Depending on the field, there are a certain number of hours required every year or every 2 years. For instance, my wife is a physical therapist. She has to have 30 hours every 2 years of continuing education to maintain her licensure. Once you get a license, I would do as much as possible to maintain it. It's actually, in some cases, harder to re-license than it is to get licensed in the first place. I taught for 6 years down at the Denver campus of College America before moving to Loveland. And we had 2 people on our medical staff, a retired nurse and a retired pharmacist, both of whom had allowed their licensures to lapse. And the retired nurse literally was not in a position to get it back. It would have cost her a fortune to relicense in Colorado. The retired pharmacist was in the same boat. She was not only a pharmacist, she was a PA, and she'd let both lapse. So, and they both regretted it because it's easier to keep a license than to reacquire it when it's lapsed. Much easier. So anyway, as I said, don't panic. We're all friends here. Nobody's gonna scream and holler and tell you you're wrong or make insulting remarks. That's not allowed. Um, but and it can be a lot of fun to have these discussions. Um, the um, the thing the thing the thing to remember is that once you start a discussion, it can go a lot of directions. So you need to sort of be willing to go with the flow. Okay. Okay. So that's the news flash. Let's talk about the general structure as well. And before our second break, after which we'll talk about math. There will be math review. There's a math worksheet in each of our weeks. There are drug worksheets that you're going to work on. I will have some handouts for you before you leave today. And we have labs. We have quizzes. We have about drugs. The quizzes can be taken as many times as you want to get the best grade you want to have. Okay, so there's no excuse. Pardon? There is no connect work with this. Our textbook is not associated with McGraw-Hill. So we have the labs. This first week, we're going to be working with solutions. We'll do that on Wednesday. And the second week, we have capsules, and the third week, we have ointments. Okay. We have we'll talk about routes and the relationship of the route of administration to the formulation of the drug. Some of that's going to be pretty obvious. Pills, tablets, capsules need to be taken orally. They can't be injected, that sort of thing. So, I mean, some of it's obvious, some of it not so. Okay. So we'll talk about the relationship between routes and of administration and the formulations. There's a couple of videos in the week one blended learning that you should watch, measuring liquids, emulsions. Emulsions are, that solutions are when something dissolves completely in something else and you can't see any different phases or different, you don't have solids. You see this all the time, and you do this all the time. Emulsions are mixtures of liquids that don't dissolve in each other. And liquids that dissolve in each other are things like alcohol and water. They mix quite readily with each other. But oil and water, obviously, do not. But you can make very finely suspended particles of oil in water, and that's an emulsion. Emulsions are relatively stable, meaning once you make them, they'll stay in that state, and they're usually opaque. You can't see through them. They'll stay in that state for quite some time, but they will eventually settle out. One of the most common emulsions we have is milk. Okay. We have a drug list that you should study here each week for the drug quiz. That you're going to drug test each week, small test. This is really to start you understanding that we need to learn about drugs. We need to be able, when somebody comes in and asks a question about, say, Seroquel, you need to be able to answer their question very quickly. Okay, so we want you to start doing that. You also have a discussion. This week's discussion is really related to formulations and routes of administration. Give 3 reasons why a drug may not be used for oral administration and 3 reasons why it may not be used for parenteral, meaning injectable administration. Okay, explain why it's important. Okay, so you're going to have a discussion each week. I hope that everyone all three of you in the class will participate because, of course, it's the usual structure. You make a principal post, and then you should respond to 2 other postings. Okay, so that being the case, I hope that all 3 of you will participate in that. So there'll be a discussion in each week, the first 3 weeks of class. Discussions are due. The primary posting is due Wednesday night, midnight. And then your responses, and this is where I differ from many here at the school, your responses will be due by Sunday night, not Saturday night at midnight. Part of the reason is, quite frankly, I will not be spending my Saturday nights looking at grading. I don't expect you to spend your Saturday nights doing this either. I suggest you do things early. But remember, my due date is Sunday, and I think I've got that in the syllabus, except for the last week. I want everything by Thursday because, of course, that last week and the weekend that follows it, 2 things are going on for instructors here. One is we're grading for our mod that's ending, but we're also setting up our classes for the mod that's going to begin next week. So I like to have all that material by Thursday evening, Thursday night, midnight of that last week of class. Okay. So that's what we're going to be doing this week in terms of assignments. Let's take our second break. It's now 10:32. Let's take our second break, and we'll come back and talk about math.
I'll just put that on my phone.
Okay. Do you know where Sarah E went?
I'm not sure. I just seen her in the restroom, so that was in the first one I'll bring.
Okay.
I'm not sure.
No. We'll get started in a moment on math.
You was just talking to her in the computer.
Yeah, she might very well be. Okay, so we're going to talk about math. We have a PowerPoint that you have access to. But we use math all the time. I don't know if you're among the people who is freaked out by math or not,
A little bit.
but
Just because it's hot.
yeah, very differently. The fact is you use math all the time. And the math that we use in pharmacy isn't a whole lot different from the math you use when you're modifying a recipe when you're cooking, really. But we do have numbers that appear. One of the things that, that we do have is the difference between Arabic numerals and Roman numerals. Both are still used. Obviously, Arabic numerals are what we use for almost everyday activities. We call them Arabic, even though the Arabs stole them from India originally. But nonetheless, that's how they came to us in the West, was through our contact with the civilizations in the Middle East. So I won't bother to explain Arabic numerals to you. You know, use them all the time. Roman numerals you may or may not be familiar with, but the Romans used letters as substitutes for numbers. Okay, and we still use them today, and some doctors will use them as prescriptions today. So in Roman numerals, the letter I, which can also be abbreviated small, equals a 1. The letter V, or V, equals 5. The letter X, or X, is 10. Now there are more. Okay. L is 50. C is 100. M is 1,000. Rarely will you see this in medicine, okay, if ever. Why do we care? Well, because sometimes prescriptions will be written using Roman numerals. For instance, you may see a prescription that says Vicodin, 10 milligram, Q4H and pain. Okay. How that reads is Vicodin 10 milligrams, take 2 tablets every 4 hours as needed for pain. Okay. But note these are Roman numerals. Now, unfortunately, doctors' handwriting can be pretty bad. That's pretty readable. But what you may see is we also have, we can put a line over it, or we can go put a line over that. So we can, there are several different ways of writing out these Roman numerals. You just have to get used to the individual from doctors. There are plenty of examples of this. The other thing that may happen is you will see sometimes doctors make it easy to fill a prescription by telling you exactly how many units, tablets or capsules, that says give the patient 10 tablets. Okay. Now, many doctors will write out the number using Arabic numbers, but others will use these. I've actually seen one prescription where it was that's 300. 100 plus 100 plus 100. When you're writing and reading a numeral, Roman numerals, you simply add the letters. So this is a 2, 1 plus 1, but there are never more than 3 of the same letter in a row. When you have to go to 4, you have to basically, you put a lower number in front of a higher number, and that subtracts 1. So 4 is IV. 9 is IX. You don't have VX, however, because V is 5. Right? But you can have XL, which is 40. Okay, so when you're reading a Roman numeral, you always start with the highest number. So if we want 106, would be 100 plus 5 plus 1, CVI. 104 would be CIV, because we have a lower number followed by a higher. Now, the Romans did this easily because that's what they grew up with. But we have to get used to that notation in this society because we're used to the Arabic notation. The Romans have no symbol for 0. Not necessary. C is 100, 100 in Arabic. Right? So we didn't have to worry about the placeholder 0 that tells us where the decimal is. That's what that comes out. Okay. So that makes sense to everyone? Okay, so you're going to see those in prescriptions on a regular basis. And as I said, you can create any number by simply stringing them together, but start with the highest. If your number is 63, you'd start with L, 50, plus 10 to get to 60, so LX, plus 3 I's. That gives you 63. But remember, no more than 3 of any number symbol in a row. Then you have to jump to the next highest and subtract. Okay. So 150 would be CV. 140 would be CXV. So the Romans knew how to do this very well. In fact, they created some rather wonderful structures using their mathematical system. So it works. But we still see it sometimes. Okay. Not going to go through all of this stuff because I don't want to spend a phenomenal amount of time on it. You've all got this PowerPoint, so you can follow along. Terms that we use: decimal. It's a type of fraction. In reality, you all know about decimals. 0.40 is 40 hundredths or 4/10. You've all dealt with decimals before. We deal with it all the time. $1.99 is 1.99. $1.99. Okay. In fractions, we have denominators and numerators. The denominator is the bottom number in a fraction. The numerator is the top. We convert that into a decimal by dividing the numerator by the denominator. In the pharmacy and in my class, use your calculators. Okay. You have a calculator on your computer. You all have calculators on your phones. Use calculators. Because you don't get partial credit for doing it right and getting the wrong answer. In the pharmacy, if you get the wrong answer, you could hurt the patient. It's critical to get the right answer. So even when you take the pharmacy certification exam, pharmacy technician certification exam, they give you a calculator. It's a simple calculator, But that's all you need to do is add, subtract, multiply, and divide in pharmacy. So they'll give you a calculator because you'll have a calculator in every pharmacy that you ever work in. So as I say, there is no partial credit for getting the wrong answer but doing it right. This is not a math class. This is a very much a get the right answer or it's wrong class. One of the things that you'll be doing in your math exercises is calculating some doses. Ask yourself always, does this make sense? For instance, if someone just gave you a prescription for Vicodin, instead of just limiting the number of tablets, they said for 10 days, okay? You have to calculate. If you come out with an answer that says 3 tablets, well, you know right away that you made a mistake because that answer doesn't make sense. If you can take 2 tablets every 4 hours for 10 days, you know, that should be fairly easy to see that you've got 6 doses or 12 a day, should be about 120 tablets. Now, you won't ever have a Vicodin prescription like that because we restrict the number of tablets. But nonetheless, you can look at it and say to yourself, oh, I calculate 12 tablets. That doesn't make sense. Excuse me. Or I calculate 300 tablets. That doesn't make sense. So look at when you do a pharmaceutical calculation, look at every one critically and ask yourself if the answer makes sense. When we calculate doses that are for injectable products, for instance, there are limits on the amount of drug you can put in an intramuscular or subcutaneous injection. If you come up with a number that's in excess of that limit, then you need to go back and look. You have to just ask yourself every time, does it make sense? And how do you know it makes sense? By doing lots of calculations and getting a sense of where things go. It's all about practice, which is why you're going to do math every week in this class. Okay. Reciprocals. Basically, if you want the reciprocal of a fraction, you flip it over. You make the denominator the numerator and the numerator the denominator. So the fraction 2/5, the reciprocal is 5/2, 5/2, or 5/2. Another definition is that the reciprocals, if you multiply them together, equal 1. Okay, we'll talk about adding and subtracting and multiplying fractions. We've got things like whole numbers, also known as integers. Whole numbers are exactly that. They are 1, 2, 643. Those are whole numbers. We also call them integers. That's the fancy mathematical name for a whole number. Okay. So we have lots of terms. Okay. So what we want is an understanding of how we use these different concepts. We're going to talk about fractions first. Okay, so by definition, a fraction is a part of a whole. The whole being represented by the denominator and the part being represented by the numerator. So if we have, and please forgive my artistry, I am not an artist, but if we have a pie and we've divided it into 5 pieces, and we're going to assume that those are all equivalent size. You know how you get your children to divide a pie into equivalent size pieces? One does the cutting and the other gets to choose which piece they want. you'd be surprised. You won't be able to tell the difference between the size of the pieces of pie or cake that they cut. Okay, that's one way of doing it. The other is to pretend. We're going to pretend. Okay, so this section of the pie is 2 out of 5, 2/5. Okay. So we can have, if we have 2 pies, okay, and we take 2 parts out of this and all 5 out of that, we have 7 parts out of 5. We still have each pie is 5 parts, but we now have parts of 2 pies. Also known as 1 2/5. We have 3 different kinds of fractions here. One kind is what we call a proper fraction, where the numerator is smaller than the denominator. We have an improper fraction. Anytime you hear in science or math a term like proper, you know there's an improper that's coming next, okay? Where the numerator is larger than the denominator. And then we have a mixed fraction, where we have an integer followed by a proper fraction. And you can see that we can convert these things back and forth. All we've done is divide 5 into 7. We get 1, and then we have 2/5 left over. That's how we convert these things back and forth. Okay. There's another kind of fraction called a complex fraction, in which one or both of the numerator or denominator is a fraction. Okay, so 2/5 over 5/8 is what we call a complex fraction, because the numerator is a fraction, the denominator is a fraction. It can also be 1 over 5/8, because all it has to do is have one of those 2 of the denominator or numerator as a fraction. We're not going to see very many of those. So I'm going to just let you know that they exist, and we're going to deal with the rest of them after that. Fractions can be added and subtracted. Okay. When we added a whole pie, 5/5 of a pie, to the 2/5 we already had to get 7, the principle is that 2/5 plus 5/5 is 7/5. What we do is, if the denominators are equal, we add or subtract the numerators. If the denominators are not equal, 2/5 plus 5/8, we have to find a way to make them equal. And one way to make them equal is to find what we call the common denominator. What's the way to find a common denominator? Well, multiply the 2 denominators together. That's one way. If we multiply 5 times 8, we get 40. Right? Now, another principle is, if you multiply or divide the numerator and denominator by the same factor, the fraction remains equal. Okay? It's an equal fraction. So, for instance, 2/5, if we multiplied by each of the numerator and denominator by 2, we'd come up with 4/10. Those are exactly equivalent fractions. Okay? Because if we take the 2 out, we still have the 5/5. So what we have is, if we want the denominator to be 40, if we multiply 8 over 8 times 2/5 plus 5/8 times 5 over 5. Why do I choose that? Because we have multiplied the 5 here to get 40, and we've multiplied 8 times 5 to get 40. So we want to multiply. Anytime you multiply 2 fractions, remember, 8 over 8 is 1. 1 times anything is the thing, right? So 1 times 2/5 is still 2/5. That's why these are equivalent. Picking up goodies. All right. So now we multiply. We've got 16 over 40 plus 25 over 40. And now we just add the denominators. Now we get 41 over 40. Okay. Make sense? Now, as I said before, we're going to multiply next. Multiplying fractions is easy. You simply multiply. If we want 2/5 times 5/8, we simply multiply numerator times numerator and denominator times denominator. So this becomes 10/40. Now, next principle, 10/40. Each of 10 and 40 is divisible by 10. So if we divide each of these components, we divide the numerator and the denominator by 10 each, we get 1/4. This isn't a math class. So I would accept either of those answers as correct. You have a quiz, and you end up with getting getting it stated to be wrong, even though you've done everything you think right. Check to see if you can reduce it down. Okay. As I said, I would accept it on a written. Unfortunately, the quizzes that we have set up in Canvas are not smart enough to be able to do that. However, if you think that you've gotten something right, it's marked it wrong, let me know. I can go back and check and see what happened. I can fix that. I can always change grade. Division is a little more complicated. But not very difficult. If we're going to divide 2/5 and we're going to divide by 5/8. Okay. Now, note that this symbol is translated as divided by. That means that we are dividing 5/8 into 2/5. So this can be actually expressed as a fraction, 2/5 over 5/8. So this is the denominator. This is the numerator. Okay. Or to use another mathematical term, this is the divisor, the thing doing the dividing. We always read, when we use mathematical symbology, we're reading left to right. Okay. So what the rule is, we have 2 steps. One, we invert the divisor. And the second step is then we multiply. So what we have is, if we're going to invert the divisor, this now becomes 8 over 5. And when we multiply, we start with our 2/5 and we're multiplying by 8 over 5, and we get 16 over 25. Okay. Now the order presentation here is critical. Let's look at the other problem. 5/8 divided by 2/5. So our first step, we're going to invert the divisor, 5/2, and we're going to multiply that times the other term. And now we have 25 over 16, which is the reciprocal or the inversion of that. So the order matters. So you need to be aware that you do this correctly, or you'll get exactly the wrong answer. Okay, so that's how we manipulate fractions. You happy with that? All right. Okay. I suggest that as part of your study that you look at go through the PowerPoint and do a couple of the examples. Let's use another bit of terminology, especially as it applies to fractions. Okay. And use some of the other language that we will run into when we're doing math problems. Okay. What is 2/3 of 3/8? Okay. When we have a term like 2/3 of 3/8, we're multiplying 3/8 by 2/3. So this is really saying we're going to multiply 2/3 times 3/8. 2/3 times 3/8 is 6/24. 6 goes into 24 how many times? Pardon? Yeah, if you divide 6 into 24. 4 times. So now this becomes, again, 1/4. Right? As I said before, I'd accept either of these because this isn't a math class. It's a pharmacy class. But I want you to understand how to do these. Okay. So this is the same thing. 2/3 times 3/8. Okay. Make sense? So if you see something that says, what is 2/3 of, say, 50, you know you're going to multiply 2/3 times 50. Remember that an integer is an implied fraction with a denominator of 1. So 2/3 of 50 is the same as 2/3 times 50 over 1, which is 100 over 3. Right? So we want to remember those basic principles. So we've talked about dividing. In our problems, you will always either see things like 1/3 divided by 1/2, which means that 1/2 is the divisor. Again, or you'll see the division symbol. Or you'll see the angled slash. Now, when we're dealing with fractions, we are really hesitant about using the angled slash as our divide symbol because it's very easy to get confused as to what's dividing into what. So you'll be told directly. It should be obvious from the problem. Decimals, okay. Clearly, decimals come in two basic different kinds. Decimals that are the entire number is less than 1, and decimals where the where there is a digit, there is a whole number first, followed by a decimal number. In the pharmacy, we will be actually occasionally having to calculate a weight or a number. So we have a couple of rules that we follow. Everyone knows that if you divide, that you can convert a fraction into a decimal by dividing the numerator into the denominator, or the denominator into the numerator. So 5 into 2 goes 0 times, right? So then we start adding decimals and then adding zeros. Now 5 into 20 goes 4 times, so we get 0.04. 0.4 is often the answer that people put down. In the pharmacy, we have what we call a leading zero. If there is no digit to the left of the decimal point, we always put a 0. Why is that? Because when doctors write out prescriptions, they may or may not make the decimal point clear. Or if the prescription is faxed to you, that may not come through. But the zeros going to be there. Doctors and nurses are real good about this, about putting that leading 0. Now, if the number is, say, 33, we do not add a 0 in front of it, because the implication is that there is a decimal point there. So there is no leading 0 on integers or fraction or decimals greater than 1. Okay. Also, we don't use trailing zeros on whole numbers. If our number is 33, in the pharmacy, we don't put a 0.0, because if that doesn't come through, that number is 330. In other words, 10 times the value it should be. So in the pharmacy, and in any math I do, you will see me use the leading 0 for any decimal that is less than 1. I urge you to do that. As I said, doctors are good about that. Nurses too. They understand the necessity. And yes, you do have sometimes doses that might be, say, 0.4 milligrams of a drug. Prime example, nitroglycerin. You're going to see it as 0.4 milligrams. And it always puts a 0 there at the beginning. Nitroglycerin is a very potent drug. Rounding. Our calculations can sometimes give us some fairly large numbers, and we can't just carry them out forever. If we divide 3 into 100, right, we're going to get a number that will go on forever. 3 into 100 is 33.3333, and it goes on forever. We can't write that down. So we round things off. Depending on the circumstances, we choose which of these decimal positions gets rounded to. Let's just say if we want to round it to 2 decimals, in other words, to 100th, what we do is we look at this very next digit, and if it's 5 or more, we add 1 to the previous digit. If it is 4 or less, we simply drop the rest of them. So in this case, we'd have 33.33. But if our number were twice that, 66.66666, etc., we look at this, we want to round to the hundredths, we look at this one, and this becomes 6.67. Those are the rounding rules. But we have to know where to round it. If you're asked a rounding question, you'll be told to round it to tenths, hundredths, or thousandths, or 1, 2, or 3 decimal places. Okay, it will make it very easy. We'll make the problems clear. You all know how to multiply and divide decimals. And remember what I said, always use your calculator. Always do problems on the calculator twice. And if you can find a way to reverse them, if you're multiplying 2 decimals, multiply it, write down your answer, and then multiply it in the reverse order, because that'll give you the same answer. If you get a different answer, then one way or another you made a mistake, so you have to check it again. But but do what you can to look at exact, to look at getting to do what you can do to do the problem differently the second time. Now it's a little hard if you're doing a division to divide it any other way. So just do it twice and make sure. And the reason I suggest that, I mean, calculators will do what you tell them to, but if you accidentally hit the wrong digit, and depending on the size of the calculator, that's easy. One of my very first calculators was a scientific calculator that was the size of a credit card. So it had about 30 buttons on it. Very easy to hit the wrong button. So just check it out. And phones, the screen's pretty small, so sometimes you have that problem too. Okay. Let's look at measurement systems. In the pharmacy, we actually use 3 systems. We used the metric system. We used an old system. You'll still find people occasionally using a very old system called the apothecary system. And we use the household system. There are lots of reasons that we have this mixture of systems. The apothecary system is basically a holdover from the old days when we didn't have a standardized measurement system. There are many hospitals and medical systems that have banned the use of apothecary measurements, and I'll show you why later. But we're going to focus on volume and weight, although length comes into it as well. And we're going to take that up actually after our last break of the morning. So let's take 10 minutes and we'll come back and talk about these various measurement systems. It's important that we understand it. I trust you guys understand the metric system pretty well. You probably used it a lot. But I know you haven't ever used the apothecary system. Most pharmacists have never used the apothecary system. So, but we'll talk about where we use why and what, okay? It is, isn't it?
What are your hobbies?
Sorry?
What are your hobbies?
I do a lot of things like woodworking. So we've done a lot of that around our house. And to a lesser extent, I've sort of been dragged into gardening by my wife. Never been something I was terribly interested in.
You guys grow roses?
We do. And that's what really got me into it because yeah, our first house that we owned many, many years ago in North Carolina, we planted 27 or 28 rose bushes. So we had roses all the time.
It smells so good.
Yeah. When you actually grow them.
Mhm.
But we've put several into we've got 4 in the house that we bought in Loveland. The previous owner had had a bunch of old roses that had reverted to wild stock. Um, so we pulled most of those out, but one of them, a really nice yellow rose, was still in good shape. So we left that one. And then we got 3 more that were just unbelievably fragrant. And my wife loves irises, so we have a nice long iris patch out back as well. So, but we do that. We put in a bunch of raised beds this year we grew some vegetables and stuff, with varying results. But we've got that. We just have been working on making our yard nice, a nice place. The previous owner took care of it, but he wasn't a gardener. And I think his wife might have been, but she had died several years before, and I think he just kept it up.
Right.
So, and I can't blame him. If it's not your thing. I mean, he obviously was a woodworker, but a really, really tremendous guy. But that's what I do. I do that.
And
And
what are you gonna do? Find someone who can make them from your family? Do you know what I'm talking about?
yeah, I do.
I've been wanting, probably like I said, but I want it like wooden so I can put holes and top the light bulb. But
Yeah, that's out of my league. I have a friend in Greeley who, as long as his health holds out, he does a lot of woodwork. That is his hobby, and he's good. But it's hard to find, and you can't find anything that you like at any of the stores.
well, I just want it made. Because I want it
Yeah,
it's just like small.
yeah.
I want it really big.
My mother-in-law's longtime friend was an engineer and a woodworker, and he actually built her something like that. And that mirror that he made weighs a ton. Um,
The other one I seen that was that place with like shipping and all that stuff.
sure, yeah. Well, it probably cost you to have it made by someone. It probably cost you close to that. And of course, if it's quality work,
Yeah.
it's worth it because it's probably the last one you'll ever buy.
Right.
But yeah, yeah, we spent a lot of time. I didn't build the cabinetry in our kitchen. We actually ordered it, but we mounted it when we changed out our kitchen, and the stuff we had in it when we bought the house was fine. It's just that we had had oak cabinetry for the last 40 years, and we just said, no, we want something different. And so we ordered it all, had it delivered, and then we mounted it all. That was a fun task. But yeah, as I say, I have a friend in Greeley who does that kind of work. Yeah, I've done a couple of those. Yeah. Did a couple at our previous house. Haven't done any here. We don't really need it. We have an incredible backyard that's just full of birds already. And so the birds, I think, help keep the squirrels under control.
Yeah.
Because they'll chase the squirrels off.
Well, at my house, there is a lot of birds. And the reason squirrels don't come around is because our cat gets
Yep. Yeah, cats can be a good way to do it. Yep.
Before we moved in, so we had a kitten. And it was a hobby, and a cat. She was
Yep.
She started a family there.
Well,
Because
cats
a lot
are
of
cats are
things-
good.
Yeah.
Cats are good. I don't know. Are they outside cats?
Mhm.
Yeah. Yeah, we had to rabbit proof our backyard this last summer. Yeah, we didn't mind the rabbit coming in and chewing on some things, but when this rabbit started eating the roses, I mean, literally stripping all the new growth and was going to kill them. We basically the thing was we need to either keep the rabbit out of the yard or the rabbit's going to have to be killed. I don't just randomly kill things. So I figured out how to keep the rabbit out of the yard. I put up a barrier that it couldn't get through. And we haven't had that problem. So, but we do have a lot of rabbits. And rabbits are a pain. I didn't, as I said, it was annoying when it was eating the snapdragons, but when it went after the roses, that was the end.
My goodness,
Mm-hmm.
thank you. She got out. And they bring some big old rabbits too. They're not really fun.
Yeah. Well, this rabbit started off as basically a little bitty baby rabbit coming into our yard and just sort of eating the grass. And yeah, we sort of ignored it because, and it got to the point where it wasn't afraid of us. I mean, it would run away if we got too close, but it wouldn't bolt at the first sight of us because we never really did anything to it. But then when it started after the roses, that was, you're finished. You're either going to have to be, we're going to have to either kill you or keep you out. So I figured out a barrier. Okay, let's talk about the metric system briefly. Again, I'm not going to spend a lot of time, but metric calculations are what we use in the pharmacy because apothecary is not good enough. I'll get to that in a minute. And the household measurement system isn't accurate. We do all of our calculations in the pharmacy for dosing, whether it be for solid medications, liquid medications, whether oral or injected, doesn't matter. We do all of those calculations using the metric system because it is an easy system. You all know that it's based on powers of 10. Mainly in the pharmacy, we're going to be looking at volume and weight. We rarely so we won't go into that. Volume and weight we will deal with. The basic unit of volume is the liter, which is approximately 1 quart. That gives you that. The basic unit of weight is a gram, which is about 1/30 of an ounce. So a very small amount. But we use multiples and fractions of liters and grams. We have, I've put together a little conversion rubric, grams, liters, or the basic unit of length, the meter, okay, which is about 1 1/10 yards. So we have that. The larger unit that we commonly use for any of this is the kilo, which is 1,000 times any one of these. Now, the only place we'll use kilo in our calculations is in patient weights, because we often dose based on their weight in kilograms, 1,000-gram units. A kilogram is about 2.2 pounds. So we can, even though our systems here are designed in many cases to weigh patients in pounds, we can quickly convert. Now, of course, all of your electronic weighing apparatus, you can flip a switch and it will give you metric or English measurements. So it doesn't matter. You can measure it that way. But we often have to do that conversion. Smaller units are based on fractions of the liter or the gram. We have 1/100th, which is centi. So a centigram is 1/100th of a gram. Okay. Or milli, which is 1,000th or 1/10 of a centigram, would be a milligram. Mainly when we are dealing with centi, it's in length measures. When babies are born, we measure their length. We can measure in inches or in centimeters, 1/100th of a meter. We often have to make that conversion. But in terms of volume and weight, we use milli, 1,000th, so a milliliter, okay, which is always abbreviated M capital L. Now, the reason we do that is because most textbooks will abbreviate M with a small l. Well, that could be mistaken for M1. We are all about making certain that any casual errors are prevented. So when we are talking about measurements in milliliters, we always use the capital L, or in liters, we always use the capital L. Now, a milliliter is a very small amount, so we don't generally go any smaller in the pharmacy than a milliliter. In terms of weight, we have milligrams, 1,000th of a gram, and some of our drugs are so potent that they're dosed in microgram amount, meaning 1/1,000,000th. Okay, so these are the general conversions or general levels of fractional division that we use. There are many more. There is one for every power of 10. So there is a tenth, which is deci. There is 10 times, which is deca. Okay. We don't use those in the pharmacy. They're not convenient. All right. So if we're converting these things, and often we have to, because in calculations, you can't have different different levels of units of the same parameter, like different levels of weight or volume. So we have to make them unified. So what we want to do is when we are converting, say, grams to milligrams, we're moving from left to right on this chart. We multiply by the factor above the arrow. Okay? And we multiply by the factor above every arrow that we cross. Okay? So if we want to convert a number of grams to milligrams, we multiply by 1,000. So if something says 2.5 grams, 2.5 times 1,000 is 2,500. 2,500 milligrams. We want to go to micro from there. We again multiply by 1,000. So that 2.5 grams becomes 2,500 milligrams becomes 2,500,000 micrograms. Okay. If we're going the other way and converting, say, milligrams to grams, we're going to divide by 1,000. So if we have 500 milligrams and we want to convert that to grams, we divide by 1,000 and we get 0.5 grams. Does that make sense? So if you write down this little conversion rubric, if we're going from left to right, going from larger to smaller divisions, we're multiplying. If we're going left to right, we are now dividing always by the amount above the arrow. Don't get confused and do divide by 100, divide by 10, and then divide by 1,000. Remember, this arrow goes directly to milling. Okay. The only reason that I put in centi is because we do use centimeters in a measurement, such as if we were setting up IV tubing, we would measure it in centimeters. Okay. That makes sense? All right. One of the beauties of the metric system is its internal consistency. Okay. If we look at a meter and we divide that into centimeters, and a centimeter is about 4/10 of an inch, about that long. If we look at volume and we look at the volume of a cube 1 centimeter on a side, this is a cubic centimeter. Also known as a cc. A cubic centimeter is 1 milliliter. So we've related volume and length right there. Now to take it to the next level, 1 cc or 1 milliliter of water under very specific conditions, in this case at 4 degrees centigrade, pure water, okay, for lots of reasons. Water at 4 degrees centigrade is just before water freezes at 1 degree centigrade. It happens to be the point at which water reaches its minimum volume. When you remember, when you cool things down, they shrink. You can see that especially with things like candle wax and that sort of thing. Cool things down, they shrink. Water shrinks only so far. And then as it's beginning to get to the point of freezing, it begins to reorganize its structure and expand. So water below 4 degrees centigrade actually has started to expand again to form ice. Ice floats, therefore it has more volume per weight than the liquid form, which is a good thing. Otherwise, the oceans would be frozen solid from the bottom to the top, and we wouldn't be here. Most things, when they solidify from the liquid state, sink to the bottom of the container because they're denser. Ice floats, which is a good thing. Why ice is unique and why it is also the most destructive substance in the universe. Excuse me, my daughter was sick all of last week and I'm getting a sore throat. Okay. So one cubic centimeter of water weighs 1 gram. So now we've related volume, length, and weight. That's the beauty of the metric system. So if somebody says to you, how much does 1 liter of water weigh? You know that 1 liter contains 1,000 milliliters. So you know it weighs 1,000 grams. Okay. So we can convert these things back and forth. So we have a gram of water that occupies a volume of 1 milliliter. Okay. That's something to keep in mind for future calculations. So that's why we like the metric system so much. Now I'm going to erase this. And we're going to add in the household system. Why do we use that? Well, quite frankly, in this country, we need to use it because most of our people don't know the difference between a milliliter and a tire. They don't understand, they can't relate that volume. Most people in this country are used to using household measurements. So volume in the household measurement system starts with the teaspoon. Teaspoon is always abbreviated with a small TSP. We do not use recipe book abbreviations, small t for teaspoon, capital T for tablespoon, because people are sloppy in their writing. It's a very easy way to make a mistake. We got teaspoon, we've got tablespoon, okay, TBSP. Okay, we've got ounce, we've got cup, pint, quart, and gallon. Okay. Unlike the metric system, there's no just easy translation. There are 3 teaspoons in a tablespoon, 2 tablespoons in an ounce, 8 ounces in a cup, 2 cups in a pint, 2 pints in a quart, and 4 quarts in a gallon. So there's no really nice standard division here. So it's not an easy system to use. It's also not very accurate, because if you look at teaspoon measures, say at home, you buy a teaspoon measuring set of spoons from one source, it's going to be a little bit different from another. Okay. We relate this back to the metric system by saying there are approximately, that little squiggle line means about, approximately 5 milliliters in a teaspoon. Now, by approximately, the actual number is 4.8. But for purposes of dosing, when we are dosing oral liquid medication in a hospital, you're going to get, by people who are used to using the medical system versus people like you guys, medical system, that sort of thing. You're going to get things probably in milliliters. But at home, a lot of people don't understand that how to convert teaspoons and milliliters. So you don't tell a patient at home, take 5 milliliters of drug A, your drug for your kid has an ear infection, you get amoxicillin, you dose them like. Now, there are plenty of places that are starting to convert to dosing in milliliters, and we can give people little measurement devices. But we learned the hard way that we have to be very careful about that with most of our patients here in this country. The United States is one of 2 countries in the world that has held on to the old household or English, or what we call the one-class system of measurement. And the only developed nation that has held on. There's lots of reasons for that, mostly to do with silliness. But we measure this and we dose by telling people to say, take so many teaspoons. And we make the conversion. So we actually calculate how much the patient's going to get in terms of the volume of drug that they're going to get in their body to take home in milliliters. And then we give them the instructions in teaspoons. And then we give them a teaspoon measuring device. And that can be a dropper, it can be an oral syringe, it can be one of those hollow-handled spoon things, or it can be the little cup that comes on top of things like children's Tylenol. Right? We have lots of ways of doing this. Now, we're starting to teach people about measurements, and we'll give them, these cups will have dual measurements on them. But nonetheless, we have to make that conversion. So the household measurement system comes in volume in terms of our dosing instructions for the patient only. So if we calculate that the patient should get 10 milliliters per dose, we tell them instead 2 teaspoons.
We make that as clear as we can. And if we have time, we'll actually take the measuring device and put a little, use a Sharpie and put a little mark on it. As I said, I'm a chemist. I've been using the metric system for, I won't tell you how many years. A lot. Well, we had one of our cats a number of years ago had a tooth extracted. And when they do that, when they extract teeth from animals, dogs or cats, you give them antibiotics. We really can't keep them clean. So you give them antibiotics. And the young woman that was at the vet office gave me the prescription, and it was it was take 2 milliliters of this with a little oral syringe, 2 milliliters, and give it to the cat. And she said, "I'll show you where 2 milliliters is on the syringe." And I almost said, you don't need to do that. I've been using these things longer than your parents have been alive. But I bit my tongue because that's her job. That's her job, to explain it. So I just let her explain it and said, "Okay, thank you," and let it go. Because I didn't want to discourage her, for one. I didn't want to insult her either. And I don't get insulted, so it didn't matter. But it was something that was needed to be done. Okay. So in terms of the length, we've got the inch is the basic measurement. And an inch is 2.54 centimeters. Where does this count? Well, as I said, when you're measuring babies when they're born, you measure their length, right? But also if you have to set up an ID set for a patient, you want to know how long it has to probably be in centimeters. And or some other measurement. So you want to, we do that. In terms of weight, the household measurement is the pound, abbreviated LB. And there are 2.2 pounds per kilogram. So if a patient comes to you and you have a patient that is 55 pounds, say it's a child, 55 pounds, and you want to know how many kilograms there are, you divide by 2.2 pounds per kilogram, and you come up with 25 kilograms. Okay, makes sense? Right. So that's the only place we're going to use that conversion, is converting pounds to kilograms, and you always divide by 2.2. Okay. Now, that's all I want to say about that. We may be applying that in some problems that we'll do throughout this course. All right, good. The apothecary system. The apothecary system came out of the old Apothecaries Guild. Apothecary is just another word for pharmacist. We used to refer to apothecary shop up until probably the 1920s. In this country, it wasn't unusual to see the term apothecary shop. Now we just call them pharmacies. Also, the other part of that is that in other parts of the world, you'll see the term chemist shop. And a chemist is a pharmacist. So if you go, I used to work, the company I used to work for Wellcome, was British Fund. It was a British multinational pharmaceutical firm. I worked for the U.S. Army, but I used to travel to London several times a year to the headquarters. And, there were chemist shops all over the place. And you see this a lot in other parts of Europe. I'm not sure about Asia because I didn't read the script, couldn't read the language. but you see it in the Middle East as well. So but you see this word here, apothecary. The Apothecary Guild was an organization that basically trained people to be pharmacists. And the apothecary was a master apothecary would have an apprentice. So the guild structure was a structure that maintained the secrecy of the professions. It was the only way the professions were trained in the Middle Ages and up until modern times. So the apothecary had their own secret measurement system. It was part of their mystique. And the measurement system for volume was the drop. This is abbreviated to this day, GTT. You will see this with things like eye drops, nose drops, ear drops. You'll see a doctor will say 1 GTT, 1 drop, and that's what they're talking about. Okay. Now, this is all well and good, but the drop from a micropipette, such as what you've seen in your hematology class, is very different from a drop out of a hypodermic needle. Right? Very different size. It all depends on the size of the opening. So there was no standard. So an effort was made to standardize that as 20 drops per milliliter in some texts, 16 in other texts, and even 15. The old pharmacy text we used to use here used 16, and yet the official standard is 20. So right there, you see that there's confusion as to what that conversion rate is, because those are different size drops. They all add up to a milliliter, but 20 drops per milliliter, the drops are smaller than 16 or 15. So we don't like that measurement system. We still use these calculations in setting up IV administration. We'll talk about that another time. In terms of weight, it's the grain, abbreviated GR. And as opposed to the metric weight, we said here 1 gram, 1 followed by the weight unit. In the apothecary system, the GR comes first. So if it were 2 grains, it would be GR2. Note that one confusion is there are a number of people who try to abbreviate grams. That's absolutely wrong. Okay, we don't do that. Now, what is a grain? Well, in ancient times, it was a grain of wheat. But think about that. Are we talking Nebraska wheat or Boulder wheat? Very different size grains. So again, we decided to standardize this to the point that one grain was 65 milligrams for some drugs, or 1 grain equals 60 milligrams for other drugs. So there's no standardization. This is why we don't use the apothecary. It isn't standard. If you look on the shelf at Walgreens and you look at aspirin, typical 325 milligrams. They'll have an abbreviation, 5 grains. Okay, you divide that out, that's 65 milligrams. You go to calculate the dose of nitroglycerin, which is a really critical drug for preventing angina from reduced circulation of oxygen to the heart. You'll see that the typical dose is 0.4 milligrams, and then you'll see that effect 1/50 of a grain. That is, that divides out to 60 grain or 60 milligrams. So again, we have no standard, no true standard. So that's why we don't use it. You will, however, occasionally see some smart-alecky doctors give a dose of aspirin to grain, just to have a dose. But occasionally it happens. But that's why we don't use the apothecary system. Okay. There are also, in terms of volume, the basic volume is a drop, but there's also the gram and the fluid ounce. And there are 8 grams to a fluid ounce. So the little bitty bottles that you sometimes see things like essential oils in, those are 1 gram bottles. That gives you an idea as to what the size of the okay, question? Okay.
I think you're getting sick.
I may very well be. I hope not. Can't afford to be sick. We don't have any spare teachers. We've got 2 of our deans out for this month. So nobody to take my classes. I teach pharmacy, and I don't take drugs. I worked in that industry. I refuse to use its products. Now, that's not a flat-out refusal, because sometimes they're very useful. If you have an infection, it's a good idea to take antibiotics. I believe in short-term drugs, not long-term drugs. Fortunately, I don't have to worry about it. I don't have diabetes. I don't have high blood pressure. I don't have rheumatoid arthritis. So I can say this without a need for such things. There is a place for all of those drugs, but it's always a trade-off. Drugs are always a trade-off. Risk versus benefit. When the benefit outweighs the risk, you take the drug. When it's the other way around, you want to think very strongly about it. But I do use a lot of natural treatments. Like in one of my classes, I like people to go out and look at natural treatments, naturopathic, homeopathic type treatments, because there are tons of them, and many of them work very well. That's what I take, is a lot of naturopathic and homeopathic medications. And they seem to keep me healthy. But my daughter had a really challenging disease last year, and I think she may have passed it on, which is not very happy making. Okay. So there's a couple of things that you're going to see in terms of measurement of potency of drugs. And one is the international unit. Or unit. There is no abbreviation, official abbreviation, although a lot of people will write IU. There's no officially accepted abbreviation for unit. A lot of people will write U. Unfortunately, that can look too much like the Roman numeral 2 in small letters. It's written sloppily. So hospitals and other organizations have banned the use of anything but the word unit when you're describing this. Now, what is a unit? It's a measure of biological activity. What drugs are given by units? Well, insulin is very clearly one of them. If you know anything, if you know anyone who's a diabetic, an insulin-dependent diabetic, when they take their diabetes, they take so many units at a time, and that's what they're taking. That's what they're doing. Some vitamins, vitamin D, vitamin E, vitamin A, these are all measured in units. And these are standardized by looking at how they're manufactured. They're manufactured by basically not synthetically. They're manufactured by isolation from natural products. Insulin can now be synthesized fairly exactly, but the old method was to isolate it from things like pig pancreas. So when they needed a method, and each of those methods yields, they're not accurate enough to where you can say, okay, I got 3 grams of stuff out, that's so many units. It doesn't work that way. What you're looking for is active material. And a lot of protein drugs are given this way, things like growth hormone given by units. So the unit is determined by what we call a bioassay, biological assay. And then everything is properly diluted so that you have a package that says for insulin, 100 units per milliliter in the solution. And that's pretty standard. And that can be easily done. So we have units, and this is biological activities. Insulin is clearly penicillin and other antibiotics, streptomycin and others are given by units as well. Then we have something called the milliequivalent. In the milliequivalent, these are based on chemical combining power. So it's things like minerals. If someone is giving you a dose of potassium, they don't give it to you in terms of milligrams. And that way we can standardize dosing across different kinds of electrolytes, all their electrolytes. Potassium chloride is one. Sodium bicarbonate. People whose blood is either weight acid or weight to readjust the pH to 7.25. But it's always given by equivalence because you calculate what's needed to bring the balance of electrolytes pH back into the proper rate. These are just units of potency. When we get into calculating doses, have you guys done doses calculation already? Okay. Well, you remember when you get into calculating doses, you don't calculate number of milligrams, you calculate number of caffeine tablets or the number of milliliters of a liquid. So the measure of potency, milligrams, micrograms, units, milligrams, all disappear. So they're just a measure of the amount of drug in a unit of the package. Does that make sense? Let's give a couple of examples here. Heparin is another one that's measured by units. Heparin is an injectable anticoagulant. It's given in hospitals following surgery. Occasionally you'll see this coming home. What we have is if we are asked to give a dose, 7,500 units heparin, we have to figure out how much volume. We don't give units to patients, we give volumes to patients. This is, as I said, this is an injectable product. It gets injected subcutaneously. So we look at the source material, and the source is 10,000 units per milliliter. So let's just set up a little proportion. Okay. We've got 7,500 units over X, which is the volume that would be that would be required to give us that, is equal to 10,000 units per 1 milliliter. Okay. Again, we're looking at equivalent fractions. So we've set this up as a proportion. So using standard algebra, we cross multiply, right? So now we get 7,500 units times 1 milliliter equals 10,000 units times X. Okay. Now, if we divide everything by 10,000 units, 7,500 units, 1 milliliter divided by 10,000 units, that's going to equal X. So the units cancel out, and all we have left is volume. And that's how we dose. 7,500 divided by 10,000, I'll just come up with 0.75 milliliters. And we can easily dose that because our syringes are graduated so that we can do it. Okay. Same thing for the milliequivalent. Ultimately, the potency unit, whether it's units, milliequivalents, or milligrams, or grams, or anything else, disappears. And what we calculate is what actually is given to the patient, either a number of tablets, a number of capsules, or a number of milliliters, or a number of drops, if we're doing something like a nasal or, ears or something like that. Okay. So that's how we do that. Okay, we're going to do some more with the math in our next class, but we'll also spend half the class doing our first lab. We'll talk about formulations. We'll start right off with some math right away, but let's go back and look at our week 1 activities. You're reading. You need to read chapters 6 and 7. 6 is the calculations chapter. 7 is the formulations and routes of administration chapter. You've got a list for the drug quiz number 1. If you look at drugs number 42 to 53 at page 55 in the back of the book, you'll find them. You're being asked to make flashcards. This is a good idea. This gives you information. And then you get started on your sign-up sheet. I will give you the IdentiDrug assignment in the next class. That's part of this week as well. Basically, it's pictures of drugs. You have to go out and look for them. Pictures of drugs that you will identify. Then you have your math worksheet 1, and then we have some quizzes to do as well. All right. So go ahead and get started, especially on the reading. Get started on math worksheet 1, and we'll pick up the rest of it on Wednesday. Okay? Thank you both for being here. And I hope you have a pleasant evening, and I will see you on Wednesday.
So is it the math worksheet 1?
Pardon?
Is it math worksheet 1?
Yeah.
Do you want us to print it or?
go ahead and print it. You can print it over here and make sure that, that you're done.